Hello everyone, I hope you're doing well today. I hope you can maybe hear the birds that are singing outside. It's a lovely day. Thank you for choosing to spend some of it to listen to Chapter 3, which is on matter and energy. So in the previous chapter, well actually in Chapter 1, we introduced this concept of chemistry and said it was the study of stuff, which we defined as matter, and the changes that it undergoes. And in Chapter 1, we briefly said that matter was anything that has mass and takes up space. What we're going to do in this chapter is deconstruct that a little more and talk about how to classify stuff or classify matter based upon its composition, what it's made of, but also based upon its physical state. So when thinking about the state of a substance, I'm sure these are terms that you're familiar with from a previous physical science or general science class, but the three most common forms or states of a substance would be solid, liquid, and gas. There's actually a fourth state called plasma, and I don't mean the plasma that you get out of your arm, but plasma that's sort of in between a liquid and a gas form. You talk about that in Chem 1. What we're going to talk about in this course are the three most common states of matter, which are solids, liquids, and gases. And so in this slide, we have a picture as well as a cartoon representation of the three states of water. So when looking at the cartoon representation of water for these three states, they're all H2O, one oxygen and two hydrogens, but you can see that the molecules of water are doing different things. Their orientation is different. When looking at the solid form of water or of ice, you can see that the molecules of water are arranged in a very neat orientation. They're in a rigid structure. You can see that they're stacked on top of each other. When you move to the liquid sample of water, there's a little more movement. There's a little more space in between those water molecules. There's a little more freedom of movement. So the molecules in a liquid state have more freedom, and therefore they are not in a rigid shape, so they don't have a rigid structure to them. And then the space in between molecules in a gaseous phase get a lot larger, a lot more spread out. And because that space changes, that changes the state of a substance. So when talking about a solid or liquid or gas, we can think about those properties in terms of shape and volume based upon those states. Solids are things that have a definite shape and a definite volume. Liquids, they have a definite volume and they take the shape of the container that they hold. Gases don't have a definite volume or definite shape. Those molecules are really spread out. And since those gas molecules are really spread out, gases are easily compressible. If you take a liquid or definitely a solid and try and compress it, it's a lot harder to do because of the space in between those molecules. So you should know that matter exists in three different states: solid, liquid, or gas. And the physical state of that substance depends upon particular conditions. And one of the conditions we're going to talk about later on in this chapter is temperature or energy. So a substance exists at a particular temperature. So those are the three states of matter that we talk about in this course. Now let's talk about classifying matter by its composition, or what makes it up. So when talking about classifying matter, there are two broad categories. Matter can be thought of as either something that is a pure substance or something that is a mixture. Now, a pure substance can come in two flavors. It can be either a compound like water, H2O, or sugar. What I have written here in the upper right-hand corner is a diagram of the molecule of general table sugar. that would be considered a pure substance that is a compound. Substances that just have one kind of atom, like carbon or helium or bromine, those are elements. Those are those beautiful things that we saw on the periodic table in chapter 1. Okay? So substances come in two flavors. Substances that are pure, they can either be elements, or if you have more than one atom that comes together, you can form compounds. Substances can also be mixtures. So let's say I had pure water, pure liquid water, which is a compound, and I had pure table sugar, sucrose, which is also a pure substance. If I were to take those two pure substances and mix them together, then I have a mixture. So mixtures are composed of two or more different types of molecules combined in variable proportions. And just like substances come in two flavors, mixtures also come in two different types, heterogeneous or homogeneous. Something that is homogeneous means all one phase. So for example, taking that water and sugar and mixing it together, particularly if that water is hot, you get all one phase because that sugar dissolves. And so you get a homogeneous mixture, homo meaning same. Heterogeneous mixtures are mixtures where you can easily see the different components of the mixture. So for example, if I was to make some salad dressing for dinner tonight, if I was to take some olive oil and water and mix them together, that oil and water would not mix for reasons that we'll talk about later in the course. But you can easily see where the oil and water layers are in that mixture, and therefore, since you can see those different components, that would be called a heterogeneous mixture. So matter, stuff, comes in two flavors, pure substances and mixtures, and those categories can be subdivided as well. So basically what I just said about pure substances is written here. I'll let you read for your own. Mixtures, we said that mixtures can be heterogeneous and homogeneous. The salad looks really good. Maybe I'll make a salad dressing for this salad, but that salad is an example of a heterogeneous mixture. The components are easily distinguishable. I can easily pick out those avocados that my son doesn't like for him to have the salad. In a chemical example, heterogeneous mixtures are often encountered in the lab, particularly if you are doing an experiment and you form a solid in a liquid. Sadly, we won't be doing that this semester in lab, but this picture on the right is an example of a heterogeneous mixture in that beaker. This person is separating an orange solid from a clear liquid by a physical method known as filtration. So this mixture in the beaker would be an example of a heterogeneous mixture. Homogeneous mixtures, as we said previously, they have uniform composition throughout, kind of like salt or sugar in hot water. One of the experiments that you would do in lab in a normal semester would be investigating the amount of salt in a saltwater solution. That saltwater solution is a homogeneous mixture. It's a mixture because it has salt and water. It's a uniform composition, but you can still separate homogeneous mixtures by physical means in the laboratory by using different techniques. I have an example here of a distillation apparatus. That's something that you will encounter in future chemistry classes if you go on in chemistry. Just know that homogeneous mixtures, they have two or more different components, uniform composition throughout, but you can still separate those components by some sort of chemical means. So, if you haven't noticed from the previous two videos that I have done on chapters 1 and chapter 2, I like using these stars to illustrate or to bring your attention to slides that are important. And I think this is a good summary slide of the types of matter, how they are classified, and so you should know how to use a flow chart like this to classify different types of matter in this course. And there are some examples on the Canvas worksheet that is posted for this chapter.